Welcome to this explainer. Today, we're going to peel back the illusion of obviousness. Every single day, we casually talk about healthcare systems, computer systems, ecosystems. But have you ever actually stopped to wonder what a system really is? Well, today, we're uncovering the deep philosophical assumptions that quietly dictate exactly how we identify, map, and ultimately solve the complex systems all around us. Understanding these hidden lenses is basically the secret code to mastering complexity. To help us navigate all these deep concepts, we've put together a clear roadmap. We'll start by decoding the word system, look at the layers of systemic inquiry, ask if systems are actually real, explore how we know them, and finally, dive into language, experience, and boundaries. Let's get right into it.
So, starting with Section 1, decoding the word system. It's a word we all use intuitively, right? But we rarely define it in the exact same way. It's really a semantic abstraction that lets us talk about incredibly diverse things.
As the observer, you really have to ask yourself a surprisingly tricky question. Think about a forest for a second. Is it an actual, objective ecosystem that just exists out there, completely independent of us? Or did we just draw a convenient boundary around a bunch of trees and animals to make it easier to study? Honestly, it depends entirely on your philosophical worldview.
But despite all the debates over boundaries, almost all the experts actually agree on a basic framework. Whether they're focusing on hierarchy, purpose, or behavior over time, they all zero in on three core things. You need elements. You need relationships between those elements, and together, they form an integrated whole that shows some kind of emergent behavior.
Moving on to Section 2, layers of systemic inquiry. Let's look at the conceptual foundations that support all this practical work. Systems don't just pop up in a vacuum, you know?
There is a conceptual ladder we all climb, often without even realizing it. We don't just perceive raw reality, we filter it through our own philosophical worldviews, and that filter totally determines how we interpret systems and where we draw our boundaries. From there, we build systems thinking frameworks which finally allow us to step up to actual systems engineering. In short, your personal philosophical worldview directly dictates the physical systems you end up building. Wild, right?
Which brings us to Section 3. Are systems actually real? Let's throw on our ontological lenses for a minute.
This is where the divide really becomes clear. On one side, you've got system realism. Mario Bunge pushed this idea called systemism, basically saying the world is fundamentally made up of interconnected systems, and we literally discover them out there in the wild. But on the flip side, thinkers like Ackoff and Churchman argue that systems are just conceptual models. In this view, we invent systems in our minds just to make sense of all the chaos, defining boundaries purely based on what we're trying to figure out. Now, what's really fascinating is this third view, relational ontology. These thinkers argue that relationships themselves are the fundamental basis of reality. Think about ecology or network science for a second. An entity only really makes sense, or arguably even exists, through its contextual interactions with other things, rather than just being some isolated static puzzle piece. Taking that even further, modern perspectives in systems biology and complex adaptive systems suggest that systemic organization is fundamentally built on information. Scholars like Stonier and Vidral argue that information is a foundational property of the entire universe, right alongside matter and energy. So, physical structures, they can actually be interpreted as just organized information patterns and flows. It's a total game changer for how we see the world. Okay, let's switch gears to Section 4, how we know systems. This is all about epistemology, which is really just a fancy philosophical way of asking, how do we actually know what we think we know about these systems? The study of how we generate knowledge is so incredibly cool. Early theorists focused mainly on pure control and communication. But then, we get this massive plot twist known as second-order cybernetics. It basically says you, the observer, cannot study a system without actually participating in it. Constructivists showed that our knowledge is always colored by our own worldviews. You aren't just looking at the system, you're essentially part of the system looking at itself.
To really ground how we process all this knowledge, the philosopher Karl Popper came up with these three interacting worlds. Think about how elegantly this maps out. Say there's an ecological system out there in World 1, physical reality. Now, our human perception and awareness of that ecology happens in World 2, our subjective experience. And finally, the systemic theories and conceptual models we create to describe it, those live in World 3, our objective shared knowledge. System science is basically the bridge connecting all three of these domains.
And that leads us perfectly into our final chapter, Section 5, Language, Experience, and Boundaries. Let's look at how semantics and our lived experiences shape our understanding.
Because the word system is such a broad abstraction, different disciplines look at it through totally different semantic lenses. An engineer looks at a system and immediately sees functional architecture and performance. A biologist? They see self-maintaining organization. And a social scientist is going to see institutions and human relationships. This semantic clarity is absolutely crucial. Because if an engineer and a sociologist try to solve a problem together without defining their terms, they're going to talk completely past each other based on their worldviews.
But long before we even get to language, we have experience. Phenomenology teaches us that perception is deeply physical and lived. We almost always sense systems first, like feeling the tension of a toxic workplace or noticing the seasons shifting in your backyard. We pick up on those things way before we ever sit down to formally analyze them on a spreadsheet. Pattern perception always comes first.
And that lived experience naturally gives rise to heuristics. These are basically our brain's practical shortcuts for dealing with extreme complexity. They help us make snap judgments when things are uncertain. Historically speaking, these value-seeking shortcuts actually built the entire discipline of systems engineering itself. That would allow us to intuitively spot boundaries and juggle competing goals.
So, this all brings us to a really profound point, captured perfectly by C.W. Churchman. He pointed out that where we choose to draw the boundaries of a system is never just a cold technical decision. It is always a deeply ethical choice. When you draw a line to define a system, you are actively deciding whose voices matter, what resources get valued, and what consequences just get brushed off as externalities.
I want to leave you with this final thought. As we've seen today, systems aren't just hard, objective facts waiting to be tripped over. They are powerfully shaped by our ontology, our epistemology, our language, and our mental shortcuts. Realizing that your own hidden worldview shapes the very systems you see and build changes literally everything about how you solve complex problems. So look around you today and ask yourself, what invisible boundaries have you drawn? And what might you discover if you finally chose to redraw them?